let's compute the integral of this function. Now, the way I'm going to solve this is by using partial fraction decomposition, but I'd like to point out that you can use other methods of integration to do this. So let's start decomposing. The first step is to factor the denominator. So if I rewrite my integral, let's leave the numerator the way it is, and then just factoring my denominator, which is relatively easy, I end up with x plus 2 by x plus 5 dx. And now I can create two fractions out of this and have two arbitrary constants. So I'll have an a part, a over x plus 2 plus b over x plus 5, all within the integral. The next step is to figure out what are these constants a and b. Now, the way to figure this out is by first of all combining the two fractions. So what I'll be doing is just multiplying each one by the denominator of the other. So I end up with a times x plus 5 plus b times x plus 2 all over the same denominator I started with, x plus 2 times x plus 5 dx. And now, how to find a and b is by setting this numerator equal to my numerator that I started with in my integral. And so for the sake of computing or finding a and b, I'm going to be ignoring the denominator just for now. So I'll be distributing the a and b terms too while I'm at it. So I'll have ax plus 5a plus bx plus 2b equals to my original numerator, which is x plus 14. So x plus 14. And now I can create a system of equations by setting the terms with the same degree equal to each other. So any term containing x will be equal to each other, and then any 0 degree term will be equal to each other. So I end up with a plus b is equal to 1, and then 5a plus 2b is equal to 14. And now you just solve the system of equations like you normally would. And you could, again, use any method to do this. I think substitution is the easiest, but feel free to use whatever methods you prefer. So from the first equation, I can define b as 1 minus a, and then I can plug it into this equation where I end up getting 5a plus 2 times 1 minus a is equal to 14. So I get 5a plus 2 minus 2a is equal to 14, or 3a is equal to 12. So I find that a is equal to 4, and then I can plug it in over here, and that tells me that b is equal to negative 3. Now that I found my two constants, I can just plug them back into my integral, and then I can go from there. So now my integral is 4 over x plus 2, yes, minus 3 over x plus 5 dx. All I did was just plug in what we just found for a and b. And now you can even go a step further and integrate these all separately, which I just think makes things easier, but it's not necessary. And then 3 over x plus 5 dx. Now, if you don't recognize it immediately, those just end up becoming logs, where the denominator just is what is contained in the log, and then the numerator is multiplied by it. And these are the kind of patterns that you end up seeing when you become really familiar with integration. If that's not obvious, you could do a quick u substitution, where u is equal to the denominator. In the first one, it's x plus 2, du is equal to dx, and then it becomes a 1 over u du situation, where then you end up with 4 ln u plus c, or 4 ln x plus 2 plus c. And then if you repeat the same steps for the second integral, you end up with writing what I got my result for the first integral, 4 ln x plus 2, and then the second one is the same thing, where you multiply by the numerator times the log content of the denominator, x plus 5, plus an arbitrary constant c, and that's it.